Hi everyone. Let's solve this question from LeetCode, which is maximum subarray. Basically, the question says, given an integer array nums, find the subarray with the largest sum and return its sum. So before we dive deep into what this problem is trying to say, we have to understand some of the basics like what is subarray. Alright, I'm gonna hop over into the note here, and then I'm gonna show you some examples of what subarray means, and then also I'm gonna break it down so that it's gonna be easier for you all to understand before jumping right away to the solution or jumping right away to the actual question. So basically, the question asks us to calculate the maximum subarray sum. So before understanding what maximum subarray sum is, we have to know the idea of subarray, this little word. So subarray basically is a contiguous part of an array. So let's say you have given this array, which is 1 2 3 4, and then you are asked to find the subarrays of the array given. When question like that comes to the interview or wherever, you simply have to remember yourself that subarray basically means any contiguous part of array. Contiguous means you cannot skip any element. So let's say there are 1 2 and 3 elements. Subarray cannot be 1 and 3 because this is not the contiguous. You just skipped 2, right? So that's not gonna be the subarray. That's not contiguous. So the subarrays of all of the elements that is inside 1 2 3 4 can be 1 1 2 1 2 3 1 2 3 4. Now the way that I have broken down this is like I started from 1 and then I increased it to include 2 2 and then 1 2 3 and then 1 2 3 4. Now after successfully finished calculating from 1, I started with 2 and then I'll calculate 2 and then it's going to be 2 3 and then it's going to be 2 3 4. Same goes for 3 3 and 4 and last 4. And these are the all subarrays that we can get from this given array 1 2 3 4. And there's a little mathematical trick to find a subarray actually. Let's say you are given integer n, right? Then the idea to find subarray is basically n plus 1 by 2, the sum of natural numbers. I think this one is sum of natural numbers. So we found 4 here, right? Sorry, 10 here, right? And then if you count it, it's going to be 1 2 3 4 5 6 7 8 9 and 10. So that's how you find the subarray. All right. Now that we know how to find subarray, we can actually jump to this problem, the actual problem that we have given. So if you understand it from here, we have to find the subarrays, right? And then we have to find the subarray that gives us the maximum sum. That's the question. That's the question actually about. Before we jump right into it, how do you actually print all of the subarrays that is given? So how do you break this down actually into the code? I mean, it's easier to break it down with just a human eye, but how do you break down that into the logic and then the code? Well, for that, let's see from here. Let's say you have given 1 2 3 4 like this array, right? Now the idea is that you define outer loop which basically represents the starting point of the subarray. And then you also define inner loop, which basically defines the end of that subarray, right? There must be any starting and ending point to basically when we were finding one must have ending point to only have 1 as a subarray. And also here 1 and 2, 1 is the starting point, 2 is the ending point. So that's the thing that we need to know in order to print all of the subarrays, right? So if you see it here, I have initialized starting variable to be 0 and then it goes till it should be st. It goes till the array of size n, and then also I have initialized inner loop which basically represents end of a subarray, right? It's gonna start from the initial value because this one also represents both starting and ending point at the same time. So this will represent ending point. And then we will actually do the best part is here. You have to understand this code. This is the one that the magic happens. This will basically start the loop from the starting point to the ending point. and then it prints all of the thing that comes inside it. So if we take an example of here 1 2 3 4, right? 1 2 3 4. This is very very easy, don't panic. I'm gonna like teach you all in a second. It's gonna be very very easier for you. I'm gonna quickly dry run this so that it is easier, right? So let's say you are given 1 2 3 4. Now your job is to find the sub arrays of that. Firstly, you will go to this loop and then you will assign st, which is basically going to be 0, right? Now your end is also 0 at this point. Now you will start the loop. Here is I less than equals, you have to have I less than equals, okay? I have I less than equals. Now starting and ending points are 0. Now since I equals also 0, then I less than equal to end, right? I less than equal to 0, which is 0 less than equal to 0. Since that condition meets, it will print basically 1. So the output we have 1 here. Now this loop will go out and then it's gonna go increment the value of end by 1. Now end is going to be 1. Now see the magic. Since end has been 1, I less than equals 1, this loop will run twice and then it will print 1 and 2. So 1 and 2 will be printed there. Again, since this loop will go out again, it won't have any value, it will go here and then increment the value of end by 1 more, then it's going to be the ending value is going to be 2. Because of that outer value, the inner loop will run twice now, successfully printing 1 2 and 3, right? Same goes for 3 also. It will print 1 2 3 and 4 like that. So basically that's how you print all of the sub arrays. Now the question is that how would you basically derive the maximum sub arrays sum from this particular given nested big O of n cube time complexity solution? Now to actually find the maximum sub arrays sum using that nested for loop, we have to do a bit of optimization on that big O of n cube time complexity, because in that case we had the time complexity of time complexity of big O of n cube, and this is really bad time complexity, right? So how would we optimize that? Well, let me write that code first from the previous section, which was basically for integer start equals 0 and then start is going to be n and start plus plus, and then we would go to the ending point, which will basically start at the start and then it's gonna go till end and then it's gonna go end plus plus. So that was our the inner condition or the ending point. Now we were simply calculating the sub arrays using the for loop inside, but we would not do that here. I'll show you here why. So let's say we have 1 2 3 and 4, right? Since the starting point is 0 and then the ending point is also pointing there, I can simply assign a variable named current sum to be 0 and then calculate the current sum going to be array of end, right? So in this whole pass it will calculate the maximum sub array sum, which will basically be 1 plus 2 plus 3 plus 4, right? So it will calculate everything and then store in the current sum. After it does that, I will check if I have the maximum sum or not. So for that I would say maximum sum is gonna be maximum of current sum or the maximum sum itself. So for that I have to have initialized the max sum with some negative values. Basically I'm gonna assign int min, which is going to be negative infinity, so that when we compare here we'll always get the right maximum value. Alright, after we successfully do that, we can simply return our maximum sum at the end of the answer. It's gonna simply give us the answer. But how did we know that we had to not use the another level of nested loop here, and then we could simply just do this and we could find the answer? Well, the idea is that since you already have a starting point and ending point, you can simply use that ending point's pointer to calculate all of the subarrays sum, and then check every time if that's the maximum or not. If this whole thing is not maximum, next time the start will update, and then only this particular subarray will be calculated, which is going to be 2, 3, 4, right? And then if that's also not the case, then again it will increase, and then in the another case it will start calculating the subarrays sum from 3 to 4. But luckily we we had to just simply go to one loop, and then we calculated everything in this case, since everything was positive. So that's how you use the optimization technique in the brute force approach itself to find the subarray sum actually. But still, this question is giving you big O of n squared time complexity, which is a quadratic time complexity, and this is really a bad time complexity. So we can optimize this time complexity a bit. How? Well, there is a algorithm named as Kadane's algorithm, right? Kadane's algorithm, which basically says that calculate the sum if your sum ever gets ever goes to 0, less than 0 or negative, right? If your sum ever goes to less than 0 or negative, then assign the sum to 0, right? Then repeatedly check for the maximum sum. Alright, this is what the whole idea of Kadane's algorithm is. Well, to understand the Kadane's algorithm better, I have to show you a best example from the LeetCode itself. I'm gonna take a easier example here. Let's say I am taking this third example, 5, 4, -1, 7 and 8, which is gonna be 5, 4, -1, 7 and 8, right? 5, 4, -1, 7 and 8. Alright, so I'm gonna assign sum to be 0, and then my maximum sum is gonna be negative infinity. Now I'm gonna loop through each of these values and then accumulate all of the values in sum. So sum initially is gonna be 5, and then I'm gonna right away check if my sum, well, let's calculate the maximum sum first, right? So my maximum sum is gonna be 5 now. Now I'm gonna check if my sum, right, if sum is less than 0, then I'm gonna simply reassign the sum to be 0. I'll show you why. That might not be a good example, but I'll show you why. And then again, just go up there and then calculate the value. It's gonna be 9. Now it's gonna improve it again by 9. sum is not less than 0, then this will never go execute. Sum is gonna be 9 minus 1, it's gonna be 8. Now this maximum sum won't change since 8 is less than 9. I already have the larger value, and then it will always again go to 7. It's gonna be 8 plus 7, I think it's 15. It's gonna be 15 here, so 15 plus 8 is 23. It's gonna be reassigned as 23. I think that 23 is the answer. Let's check here, confirm. Yeah, 23 is the answer. Well, that was a good example, but that wasn't the perfect example to show for the Kadane's algorithm. So let's I'll show you this example instead. -2, 1, 3, 4. The reason I didn't show that example earlier is because it was too large and too long to write it. Well, we don't have any choice now, right? Well, if you see it here, you have -1, right? Since your sum itself is -2, which is going to be less than 0, you will assign sum to be 0. Now next time when you come here, you have one value, right? And then you will simply say 0 plus 1 equals 1. The reason we discard negative values is if we add negative values in the positive value, right? Let's say we have 8, right? Let's say we keep adding negative value. It's gonna be 6, and then let's say it's gonna be 6, 0. So it's gonna eventually become less, the minimum. It won't maximize our actual the subarray. So that's why if at any case if our sum will be less than 0, less than 0 means negative, then we will simply reassign it to 0, because it doesn't make sense. If it is less than 0, then it will eventually give us the minimum sum instead of maximum sum. So that's why the reason we do is that's the logic. So let's code this up in LeetCode, and then we should be good to submit the problem, right? I think I have already solved this problem in LeetCode. I'm gonna quickly show you all how. So the maximum sum is int min, which is basically negative infinity, and then I have initialized the sum to be 0, and then I'm going through each of the numbers in the nums array, and then I have initially uploaded that num into sum, which is basically -2 now. Now I'm going to take maximum sum, which is going to be maximum of sum and maximum sum. Sum has 0. Maximum sum is basically going to be -2, but maximum sum will still hold 0 because 0 is greater than -2. Now I'll check if sum is less than 0. Yes, sum is actually less than 0, which is -2, right? Then I'm gonna reassign sum to 0. This is the real logic of Kadane's algorithm, because it is saying that if at any point the sum becomes 0 or less than 0, my bad, then it doesn't contribute to our final answer of calculating the maximum subarray. That's why we immediately make that sum 0 so that it doesn't accumulate again. Alright. Next time we go up here, and then we will add 1, and 1 is our sum now. Then we will check is maximum sum is going to be 1 and negative infinity or something like that. What does the maximum sum holds? I think it holds 0. So 1 comma 0 is going to be maximum is 1. So sum is not less than 0, then it won't execute. Now we'll go again -3. So sum is 1 plus -3 is -2. So -2 is still not good. So maximum sum is going to be maximum sum, which is basically 1. That is going to be it. Since our sum is less than 0, which is -2, right? Then we will reassign the sum to be 0. So if you see it here, all of till now our sum is 0, because these don't contribute anything to our actual the subarray, which the subarray that contributes is 4, -1, 2 and 1, because 4 is a large number. If you add this up, it's going to be 3. Since it's not 0, then it's going to accumulate again 2. It's going to be 5. Since it's not 0, it's going to accumulate again 1. It's going to be 6. So that's how the answer is going to be 6. So this is the real logic of Kadane's algorithm. Just remember this: if at any point your sum becomes 0, reassign it to be less than 0, reassign it to be 0. That's all Kadane's algorithm is saying. Alright, thank you. I hope you watched the video and learned something from today. I'll continue to upload all of these kind of videos anytime soon.